Hello friends. I'm very sure many people are really interested to implement machine learning. But the point goes is that how do you start? What would be the first step? Well, you need a data set because based on that data set, the machine is going to learn. Now the point comes is the data set is in the perfect order so that you can straightforward start the machine learning implementation. The answer is absolutely no. You have to do sanitization over the data. And for that reason, this particular video I will be showing different processing steps that you need to do so that your data get purified and then you can start working on machine learning. So you can say this is the first episode that you have to complete successfully, then only the model can be trained. And for that reason, Python has come up with very wonderful packages, and these are the some packages we will come across one by one, and this is really important for every people who really love to implement machine learning. So first I have got one data set, as you can see right over here. I will go through these packages, but let me go through each step because over here I have got total 6 steps involved, and if you successfully complete all these 6 steps, your data is in perfect order for the model to be trained. So one by one I will get into these packages. Let's start with the first step where you are going to read the data. And I have got one CSV file right over here, and this CSV file I'm going to use it for my pre-processing. So for that reason I have to read the data from the CSV, and for that I need a wonderful package called Panda. So I'm creating an alias of pandas in the form of PD. This is a very conventional term which we often come across, but it's just a convention. You can use whatever term you feel like. So pd.read_csv, this is a function that is going to read the data of the CSV file and store it inside the reference. I've given the name of reference as data, and this is going to be a double dimension matrix, or you can say it's like a data frame according to Python's pandas term. It's a data frame because it's a 2D matrix it would be. And then I'm going to print the matrix. Okay, let me run the code once to see and follow the thing much better way. So as I hit the enter, you can see over here lot of output are coming. Don't get yourself overwhelmed with all these output. Just focus on what I'm saying. Right now I'm focusing on this particular piece of code. Okay, so over here, after I have read the CSV file, I'm printing the data. And see over here, let me take you to the CSV file as well. I have got one column called city, age, smoke, happiness, index, and over here is actually index, and then healthy. So these are the columns that you can see over here, and the following are the 10 tuples you are seeing right over here. Okay, so 5 all total, 1 2 3 4 5 columns are there, and then we have got 10 rows. So I just counted how many number of columns are there, how many rows are there, because the data set is very small. But if you have a huge data set, it becomes very difficult, next to impossible. So for that reason we have got a very important function that is called shape as provided by the pandas. So I can go for and print the shape of that resource over here. So that's the reason I have mentioned that x size is 10. So what does 10 means? I have got 10 tuples starting from 0 to 9 index, and I have got 5 columns. These are the 5 columns which I'm referring. So I have successfully able to read the data from the CSV file into my Python application, and I have been able to show the size of my data set or the volume of the data set, that I can show it very successfully. Now let's come over here, and now comes one of the very important part, is that how do you split this data? Now why do I need to split? The reason is we are implementing supervised algorithm. Supervised algorithm says that I will give the data much in advance, and I will also give the output, and according to that the machine will be learning. So there will be certain columns, certain features. By the way, I am using the term column. I can use also the term called features. So there are certain features are there which is going to be the input feature, and there will be a particular feature which is going to be the output feature. So I need to differentiate from my data set that which particular feature I will be considering as input, or I would say that it's an independent, and which particular feature is the dependent one, which is my output. And for that reason I am using a very wonderful method that is called index location. So let's see this particular. First let me read you this particular comment, that is I'm going to segregate the input feature, and or we can call it as an independent feature. And the way we do is that with the help of the resource called data, I'm going for the ilocation, and here I'm mentioning the exact position of the data set which I'm going to extract, I'm going to segregate. So I'm saying that I need to read all the 10 records. So for that reason 0 to 10. Okay, let me tell you one thing over here. The 10 means the upper bound is not inclusive, so it would be up to 0 to 9. So 0 to 9 means all 10 records perfectly well. So keep this thing in mind. The upper bound is not inclusive, it is exclusive. So 0 to 9 would be the total number of rows that would be read, and same goes over here. 0 to 4, but 4 is not inclusive, it will be up to 0 to 3. So this is 0, city is 0, age is 1, smoke is 2, and happiness index is 3. So total, this 4 record, I mean to say the 4 features, these 4 features I'm going to extract their values, and I'm going to store in the capital letter X. Usually by convention we represent the independent data in the form of capital letter, so that's the reason I have gone for X, but it is again a convention. You're free to choose whatever you want. And then I'm printing back the data. See over here, the independent feature, you see how many columns are there? There are total 4 columns. So I'm able to successfully extract those columns that are independent. Right, so this is a new reference I have created, and by the name called X. So the further processing will all be done in context to X and not in context to data. Please keep this thing in mind. So X is that memory reference or that double dimensional data frame of pandas that actually store only those columns or those features that are independent. It is not storing the dependent one. But what about the dependent one as well? And that brings us to the next statement, where I'm targeting all rows from 0 to 9. I mean, you can write in this way also, the way I've written, or you can write in this way also. That's your choice. Both are applicable. And now I'm mentioning the specific column. Since I'm targeting the last column, so I'm mentioning this exactly the last column. So I'm mentioning that you go and read the column number 4. So this is 0, this is 1, this is 2, this is 3, and this is the 4th column. And then you pick up the data all from that and store inside the reference variable called Y. And that's the reason why I'm printing this dependent feature over here. See, it has got printed all these cell value, you can say so. But look over here, one small interesting thing. In context to X, we have got a matrix which is double dimension, whereas in case of the independent, it has got a single list. And that's the reason why there's another important term which is used in Panda, that is called series. So in context to this, you can say this is a data frame. So double dimension matrix which has got rows and column, you can call them as data frame. Whereas on the other hand, a single dimension which has just got a one row with multiple column, you can think like that way also, and that's what called series. So X is a data frame and Y is a series. This is usually what happens in case of supervised algorithm, where we have got multiple independent features which are my input. Based on that, the machine is going to learn, and the learning process will be, and finally we will get an output, and that output is a dependent feature which is actually one single column which has got multiple rows, and that's the reason we call it as a series. Okay, so after you have successfully completed this entire process, you can say that you have successfully read the data. At the same time, you have created 2 different memory blocks, one for X that represent independent features, and the other one for Y that represent the dependent feature. And that's where stage 1 concludes. Now you are good to go with stage 2. I believe things are very easy to follow, right? If you just go through this particular program, definitely it will be very handy. Now if you look at the data set over here very minutely, you will observe something very interesting, and even over here also you will observe something interesting. Look at this particular column, that is age feature. Over here there is a particular cell where there is no value, right? Even in the happiness index also there is a particular cell that has got no value. So what would you call this? Well, there is no value, whatever be the reason that this particular cell do not have a value. So how would you work in this context? And that gives birth to the next heading, that is called missing data. So there would be certain cell where the data will be missing, and that's the challenge. How do you fill the missing data over here so that it does not create any impact on my model? And that brings us to something called SimpleImputer. Okay, with the help of SimpleImputer, you can replace the missing value with some data. But the question is, how would you generate the data? You cannot just generate a random data over there, right? So there has to be some logic behind creation of this particular data, and that's what the SimpleImputer is going to do. And let's see how this particular constructor is going to work. Oh, by the way, yeah, I made use of the constructor. Of course, this is object-oriented programming, so constructor would be there. So let's see about its parameter, and you need to understand this parameter very well. SimpleImputer is actually called when we have to replace the missing cell or missing data, right? And how do you figure out that the missing has taken place actually? How do you identify that? For that reason, NumPy has got a wonderful property called NaN, that is called not a number. So look over here, you are seeing NaN. So there is no number over here, not a number. Same thing, NaN, there's not a number. So this is the way you identify the cell which actually do not have a value. Whereas in other cases, this has a odd value, so this will not be applicable. It will be applicable only for that cell where the missing data is available. So, and that is what called the property by NumPy. So you can understand every Python packages are meant for working on a specific task. We saw how Panda was responsible for reading data from the CSV file, and now we're talking about the NumPy. So NumPy will help me in this context where I will be getting the data which is missing. And how do you resolve this? The simple strategy would be to go for the mean, yes, the average. Okay, so we have to find out the mean value over here. So once you calculate this, the SimpleImputer will find out which particular cell the missing data is there and what should be the funda for replacing the missing data, and that strategy which it will implement is the mean. So this is what the reference imputer I have created right now, but at this line it is not aware that which particular column it need to apply this entire concept, because I have got two columns over here. This is one column called age where I have to apply, and there's another column called happiness index. There are two I have to apply. So it is not yet aware about this. I know this video is becoming very lengthy, so what I will do is that I will complete this portion and then I will stop over here and I will continue in the next video about the rest of the part. So with the help of SimpleImputer, you understood that it will be able to find out the missing data, the location, and the strategy it will implement. Now comes how do you implement this, and that gives birth to a two important function that is called fit and transform. In many like in different blogs, or even you might see in different videos where people have used fit underscore transform as a whole, like I have also used. But what I thought is that let me split this function separately, because they can be broken apart and we need to understand what the fit function does, what the transform function does, and then as a whole if you put them together, that is also effective. But first let's understand what this function are doing individually. So let's come over here and let me tell you that what we are doing over here. So here I'm specifying that which particular column I have to target. So please follow this thing very minutely. I already said that we have to work on the reference X, so now we are working on the X. So I'm saying that look out for the reference X, which has got the independent features, and read all the rows, but the specific column is 1:2, and 1:2 means upper bound is not inclusive. So 1:2 means I'm talking about this particular column, because this is a 0, this is a 1. So I mentioned which particular column you have to focus on, and you read all the data, all the rows, and find out from there which particular cell is missing. And this would do exactly this part, that once it has figured out, and then it will calculate the mean of that particular column. But the mean will not be inserted right over here. It will wait till the transform function has been called. So when you are giving a call to the transform function, the mean that got generated right over here, that will be replaced in this particular cell. Oh my god, it's really interesting, isn't it? So feed function always calculate the mean, but it will not be responsible for implementing the mean on the desired missing cell, and that will be done by the transform. So once the transform function is called, the mean that was calculated will be replaced in this particular cell, and for that reason again I'm giving call to the same X, because I need to regenerate my mean value. And once I have done this, look over here, this cell is now having the mean value. Okay, you might be wondering how come this became like there are 3 more columns got added. How come it was initially this was the column Mumbai, London, New York, suddenly this 1001 is coming? Don't be worried, just be relaxed, just listen to what I am saying, because in my next video I will be talking about the column transformer, and that's really exciting how this particular concept is going to work. You just once you follow it, you will simply mesmerize that this is the logic that has been implemented. Okay, so just follow what I'm saying. So this is the place where my NaN got replaced by my mean value, and this is happening for the first feature, that is the age feature. I have got one more feature called happiness index. There also have to put the value. So now I'm targeting the second independent feature. This is the one I'm talking about. So what I'm saying this time, I'm not splitting them individually, rather I'm going for the combo pack. So fit underscore transform as a whole can be also executed, and now I'm saying that read all the rows from 0 to 9. Which particular column? 3 is to 4. So 3 is to 4 means this is 0, this is 1, this is 2, this is 3, and the upper bound is not inclusive. So that means I'm talking about this particular column, and after doing so, it will read the mean and then it will transform, it will implement the mean in this particular cell, and that's how the x variable is getting reformatted or rewritten, you can say so. And eventually what happening, see over here, I'm getting this particular data which is coming from the mean value, and because this is the third one, this is the first one, the second or third one, and that's how these two independent features, the missing value has been done, right? So here we conclude that what we need to do in context to missing value. So this is one of the strategy, and this strategy is implemented by the package called scikit-learn. So scikit-learn will give a call to the impute, and this will eventually come across SimpleImputer, with the help of which we are going to transform the missing value with some strategy, and the strategy which I'm implementing is the mean. This is one of the way out you can go for it. There are different other strategies like standard deviation you can implement. So this, but the common one is to go for the mean value. Okay. So in my next video, what I'll be talking about is a categorical data, how this Mumbai, London, New York are getting to be reformed, because remember these are a string format, or you can say this is a categorical information. We cannot work on machine learning keeping a string data in my data set. I need to transform that. So there has to be some logic by the help of which you have to transform your string. Even yes no is also there. So there is two column, one is city and the other one is smoke. Even your output also in the form of string. You need to reform them in some way out, so that machine learning or the model will just be piece of the numeric implementation, and that's where the categorical data will come in picture. That's what one hot encoder or the column transform will come in picture. So wait for my next video. I'm very sure you will be super excited when we go through this particular segment thereafter. Okay, so that's all from this video presentation. Thank you very much. See you soon. Bye bye.